Welcome to lesson 95. We're going to do another algebraic strategy, substitution. So in this model lesson, you're going to look to see, one, just make sure you know how to rewrite equations in either y equals or x equals form. That way you can substitute that entire expression for x or y and solve for the unknown variable. And another important skill that you can use substitution method to find any unknown variable. Once you find x or y, you can substitute to find the other variable and express the solution as an ordered pair or recognize when there are zero or infinite solutions. Let's practice our substitution strategy, and it means just that. We're going to substitute for either x or y. So that means we're going to have to create an equation where y is equal to an expression or x is equal to an expression. Let's try it with all three types of equations when we have one solution, no solutions, and all solutions. So in this one, we have y is equal to x plus 3 and y is equal to negative 2x plus 3. This is actually great because I already have the y equal to an entire term. So it really doesn't matter which one. I'm literally going to take that entire term and sub it for y. So watch what this looks like. I'm going to use the very first equation, y equals x plus 3, and I'm going to take all this and substitute it for y. So now I have negative 2x plus 3 is equal to x plus 3. Again, once I eliminate the y's, now I can solve for x. That's what I want. I want to solve for just one variable. Let's simplify this now. I'm going to, why don't we add 2x to both sides? So 3 is equal to 3x plus 3. I'm going to subtract. And I get 0 is equal to 3x. And it makes sense. The only answer, x is equal to 0. It's the only way. Now that I have my x, I can use that information to sub in for y. So I'm going to go into my next equation, y equals negative 2x plus 3. And now I'm going to substitute x equals 0. So y is equal to 3. And there's my solution, 0, 3. All right, so again, biggest takeaway when we have a substitution, you want to create two equations where either the y is equal to some expression, so y-intercept form works really well, or x is equal. And then once you have that, you're just going to take one of them, choose this one for example, and we can just sub it into the other equation. We're going to take all this and sub it into the other equation so we can solve for x. Let's see what this looks like when we have no solution. So we already know, again, this one has no solutions. So we have y equals 3x and y is equal to 3x minus 2. Again, they're both pretty easy. So I'm going to choose to take, since this one's simpler, I'm going to take this one and substitute it for y. So that's what I'm going to do. I'm going to take this and I'm going to substitute it for y. So I get 3x is equal to 3x minus 2. I'm going to move this 3x over and eliminates. So 0 is equal to negative 2. We know this means there is no solution. This is not valid. So no solution at all. What if you had tried the other way? All right. Let's say you wanted to take this and put it into that equation. So I would still have the same thing. 3x minus 2 is equal to 3x. I'd have the exact same thing and the exact same problem. So it didn't even matter which one was substituted. I end up with the same equation. And if I were to try to evaluate it, I would still get an equation that is not valid, not true. So again, if you find a situation like this, then you know you have no solution. And this means that they are parallel lines. Hit pause, jot this down. And let's try when we have infinite solutions, when the lines are the same. So we have y plus 2 is equal to 2x, and y is equal to 2 times x minus 1. What I like about this one is they're both written in different forms. So when I would see a problem like this, I would probably choose substitution and say, I'm going to take this and plug it in for y. All right, so I'm going to take this one here because it's already written in a way that tells me I can substitute pretty easily. So 2 times x minus 1 plus 2 is equal to 2x. Let's distribute. Combine like terms. So these two just made 0. And 2x is equal to 2x. So remember I told you if you have both of them exactly equal to each other, then I know that this is an infinite solution. Okay, so when we see this kind of like a reflection where one side is exactly equal, that means, again, no matter what I put in for x, I will always get the same answer. So when x equals 1, I get the same answer. When x equals 2, it's the same answer. So again, this means infinite solutions. Hit pause and jot this down. And now you know how to recognize your substitution if you have 0, 1, or infinite solutions to your system of equations. Here's our first example for today, and just like in lesson 73, this one's also pretty straightforward. I'm going to use substitution to find the solution to the system. I have two equations, and I'm going to look for an opportunity to create a y equals or an x equals. And just looking at this one, it's much easier to do y equals for either equation. So here's my plan. I'm just going to rewrite an equation to create y equals negative 4x plus 8. And then I'm going to substitute that expression for y into negative 3x plus y equals 1. I'm going to solve for x. This is just like in the last lesson. Solve for x. And if x is a number, I know I have one solution. I keep going to find y. If both sides are equal, it's infinite. If the equation is false, there's no solution. So I'm going to, again, if there is a solution, I'm going to substitute x into the original to find y. And then I'm going to check by substituting my solutions into the equations. Here's our plan. Hit pause and jot it down. Since these are written in different forms, I'm going to create one in y-intercept form so I can substitute for y. I'm just going to choose the 4x plus y equals 8. So that I have y is equal to negative 4x plus 8. Now I'm going to substitute into the other equation. So negative 3x plus parentheses negative 4x plus 8 is equal to 1. Let's distribute a positive 1 and I still ended up with the same terms. Combine like terms. And let's isolate. Negative 7x is equal to negative 7. And I get x is equal to 1. Now that I have this, I'm going to go and substitute in the other equation when x equals 1. And I get 4 plus y is equal to 8. Let's solve for y. Y is equal to 4. So my solution is 1, 4. All right, let's sub this into both equations just so we can see if it's valid. So I'll go to the first one. Negative 3x plus y equals 1. And I get negative 3 plus 4 equals 1. 1 equals 1, completely valid. Let's try the next one. Four times 1 plus 4 equals 8. 4 plus 4 does equal 8. So this one is also valid. The solution using substitution is 1, 4, period. Hit pause and jot this down into your notes. Let's do one more solving for system of equations. I'm going to, again, just choose an equation and I want to put it into an easy form. So in this case, I'm going to subtract 3y so that I have x is equal to negative 3y plus 4. Okay, now I can sub this in. So negative, because my x is negative there, negative 3y plus 4 plus 2y is equal to 6. Let's distribute and combine like terms. All right, let's solve for y. Y is equal to 2. Now that I have y, let's substitute into the other equation. And I get x is equal to negative 2. So now let's just double check. Since we have a solution of negative 2, 2, let's check this with both equations. Negative 2 plus 6 equals 4. 4 equals 4, valid solution. And let's try with the next one. So negative 2 plus 2 times 2 equals 6. Negative 2, that just turns into a positive 2, plus 4 equals 6, and 6 is equal to 6, another valid solution. Hit pause and jot this down into your notes. And that's it, Math Marvels. This is how we can use substitution to solve systems of equations. I will see you in the next lesson. Take care.